So for the next example, I'd actually like to do one of the problems out of your exercises. I'd like to do problem number 22. So go ahead and take your books out. Open up to page 372. Yeah, go ahead and take your books out. Problem number 22 on page 372 says, home electricity use. The rate at which your home consumes electricity is measured in kilowatts. If your home consumes electricity at a rate of 1 kilowatt for 1 hour, you will be charged 1 kilowatt hour of electricity. Suppose that the average consumption rate for a certain home is modeled by the function C of t equals 3.9 minus 2.4 sine of pi t over 12. Where C of t is measured in kilowatts and t is the number of hours past midnight. Find the average daily consumption for this home measured in kilowatt hours. So in this problem, problem number 22, we have C of t is equal to 3.9 minus 2.4 sine of pi t over 12. That C of t is a rate, okay? It said that's the rate at which they're using power. So let's go ahead and do this. Let's take out our calculators and let's just graph this function to take a look at it. So when I graph this function, I'm going to take a second and I'm going to put in 3.9 minus 2.4 sine, and then I'm going to do parentheses, x pi, parentheses, divided by 12, and then close my parenthesis. And then let's do our window. Let's think about this. We actually know a little bit about sine and cosine functions. So let's do this. Let's say my x-min. So if I go to window, let's make my x-min 0. And let's make my x-max 24 because we're looking at a 24-hour period. That's the day. So then halfway would be 12, and then 6, and then 18. And again, these are hours after midnight. And then this tells me that I shifted up 3.9 units and the amplitude is 2.4. So that means it's going to go down 2.4 and up 2.4. So let's make my y-min 0. Let's make my y-max 7. And then let's go ahead and press graph. Oh, and it looks something like that, okay? Where it should make sense that we're not using, the rate at which we are using electricity is decreasing until probably about 6 o'clock in the morning, which then as the day goes on, turn on more lights, power increases, the rate at which you're using power increases. And then at about 6 o'clock at night, you probably reach your max, start turning things off after dinner, all that fun stuff, and then you kind of get back to where you started. So the question then is, and notice that you're using power the whole time. This is always above 0. You're never not using power. There's always something that's taking power. So then the question asks, what is the average daily consumption? So what I'm going to do is say, well, that is just basically the area underneath this curve. So I can go ahead and say, all right, let's take the integral from 0 to 24 of 3.9 minus 2.4 sine of pi t over 12 dt. And I'm feeling kind of lazy today. So I think what I'm going to do is just go ahead and hit math, go down to fint. I'm going to put in 3.9 minus 2.4 sine of x, let's go, I'm going to use parentheses just to be careful, of x pi divided by 12. So I'm going to close that. Oops, I'm going to put my parenthesis right there. Close that, comma, with respect to x, comma, 0, comma, 24. Close parenthesis. Press enter, and I get 93.6. So that means this calculates all the power that I've used in that 24-hour period is 93.6 kilowatt hours. Okay? So again, in this case, would it matter if I did absolute value or not? No, because everything's above the curve. But with this problem, I wouldn't even worry about absolute value because it's just asking for the average daily use.